So hello everyone, welcome back to MAA101 Calculus for Science students. Like I told you in the previous class, today we are going to recap some important knowledge that is needed or a prerequisite to what we are going to learn in Calculus and MAA101. So this will span into several subtopics. We have on intervals, inequalities, absolute values, and we also have an insight on Cartesian plane, and in some parts of the topic that we are going to discuss today, we are going to have some examples to help us illustrate the topic itself. First and foremost, okay, the most important thing that you need to know in order to be able to grasp the concept of calculus is on the intervals. So it says here, given any 2 points on the real line A and B, we call the set of points between A and B as an interval. So there are many type of interval we have. As you can see in this table here, we have open interval, we have closed interval, and then we have half open, or sometimes you call them half closed. Okay, and then we have infinite, half open, and half closed. So for example, okay, here we want to discuss on geometric representation that will help you to decide, okay, what interval is valid for your solution, that we will go later on. But first we are going to go through this geometric representation. So I'm just going to draw a single line here. So we have 2 points here, A and B, and we see that A and B is are excluded from our interval. Means to draw it, you have to draw a hollow circle, okay, to indicate that at that particular point A and B, this is excluded from the interval, but every single points between A and B is are included in our interval. And then we have second one. Okay, this is the interval notation. We include both A and B. Okay, the boundary inside our interval. It is what we call as finite and closed interval. So this is how you represent it in geometric form. So first again, we need to draw, okay, our number line. Okay, then we have A and B, and instead of having an empty circle like we have in the first one, now we are going to use the filled circle to indicate the inclusion of our boundary A and B into our interval. And then we have the third type of interval notation. This is given by, you can see A here is included in our interval, but B is excluded, and then we call it finite half opens. Okay, this is the set notation. Another way to represent this notation, just a different one. We have this one, first one and second one, but it's up to you which one you are comfortable with. And to represent this, okay, again we need to draw A and B. Okay, and then we see that for A is included, so we are going to draw a filled circle, and B is excluded from the interval, then we are going to draw a hollow circle, and then we include every single point in that interval. And finally, we have infinite half open. Okay, in this case, we have negative infinity to B, and there are also cases that we have, for example, maybe A until infinity. So we are always going to use the open notation that we have here to use with the infinity or negative infinity. So one way to represent it is by using geometric representation. Okay, we have only B here. Okay, but if you wish to draw A, it should be okay, because we are going to consider every single point below B. So here B is included, so we have a filled circle, and then it goes for every single number below B. And next we want to have some recap on inequalities. So inequalities is a statement involving two terms, okay, or what we call as numbers or more. Okay, it could be two or more, and separated by one of the following symbols. So this is the opposite of what we normally use the equalities. So now we have 4 inequalities symbol: less than or equal to, greater than or equal to. So there are several properties of inequalities that you have to be able to memorize or to get used. Okay, and these are the rules or the properties. So it says here, if A is less than B and B less than C, then A is less than C. This is the ordering principle. And then the second one, we have if A less than B, then A plus C is less than B plus C, and A minus C is less than B minus C. And the third one, we have if A is less than B, then the multiplication of AC, okay, and then we have multiplication of BC. So we multiply both sides of this with C, okay, we'll get AC less than BC when C greater than 0. And we change the direction of our inequalities. AC greater than BC when C less than 0. And the fourth one, we have if A less than B and C less than D, then the addition of the first two, that is less than A plus C, is less than the addition of the second one. So A plus C is less than B plus D. So you can also replace this with less than or equal to. Okay, or you can make some manipulation. You want to use greater than or greater than and equal to, should be okay. The same properties. So if A and B are both positive or both negative, and A is less than B, then you know that the reciprocal 1 over A is greater than 1 over B. Take for example, we have A equal to 2 and B equal to 3. Okay, we know that 2 is less than 3, but certainly 1 over 3 is less than 1 over 2. This is very straightforward. So let's take a look at some examples. So we are going to try to solve example A first. So example A is pretty straightforward. It's just some simple manipulation. So in this case, we have x minus 2 over 3 greater than 2x over 3 plus 2. Then you might want to bring everything that has x, okay, into the left hand side. For example, if you prefer right hand side, then you do so. So here I will have x, okay, and then we have minus 2x over 3, okay, and then we have greater than 2 plus 2 over 3, and then you can factorize x out. You have x 1 minus 2 over 3, okay, greater than 2 plus 2 over 3, okay, and then you can isolate x on its own. Okay, you can do your own calculation. Okay, you will get x greater than 8. Okay, as simple as that. Then we have second one B. Okay, might be a little bit complicated, but not much. Okay, so we have negative 8 less than or equal to 3x minus 5 less than 7. So now we are going to add 5 on all these three, this part, okay, this part and this part. So to make 5, negative 5 disappear here, so you add 5 everywhere. So you will have negative 8 plus 5, and then you have negative 3, okay, and then you have x only, 3x in the middle, and then you have 7 plus 5, which is 12, okay, and then finally you want to remove this 3 here. You have to divide 3 everywhere. So you have negative 3 divided by 3, you'll get negative 1. Then you have x here, and then you have 12 divided by 3, you will get 4. That's it for linear inequalities. So let's see a more complicated one. Okay, quadratic or higher order inequalities. So there are few steps that you need to follow. First, you might want to polish your skills in factoring quadratic equations. Okay, which can be very useful here. Or if you are very good with your calculator, you can directly use them here. Because we are not going to focus on how to factorize, but we are going to see how you handle the inequalities. So here given to us, okay, the inequality is 2x squared plus x greater than or equal to 1. First, you might want to see this as an equation. So you can rearrange them and you have 2x squared plus x minus 1 equal to 0. Okay. First, I'm going to find the critical points. Okay. The points where, sorry, minus 1 here, where this equation is equal to 0. So after performing the factorization, you will have 2x minus 1, okay, multiplied by x plus 1 equal to 0. Then there are two things that you need to consider. 2x minus 1 equal to 0, which will give you x equal to 1 over 2. And also the second possibility is that x plus 1 equal to 0, okay? Or in other words, you have x equal to negative 1. So you have two values of x here. And then we are going to draw our number line here. So you are going to place negative 1 here and 1 over 2 here. And then you are going to try to plug in the values here, the values here, and the values here inside your initial equation to see whether it works or not. So for example, maybe I want to try to plug in negative 2 here, then plug in 0 here, and plug in 1 here. So you can plug in and you see that the values between negative 1 and 1 over 2, okay, will give you values greater less than 1, but the value here and the value here, okay, less than negative 1 and greater than 1 over 2 will give you, okay, a valid value for x. To validate this inequality means that if you plug in negative 2, for example, you choose negative 2 here, so you plug in negative 2 here, you have 2 times negative 2 square or 2 times 4, okay, you have 8. 8 minus 2, and then you have 6. That is greater than or equal to 1. So it's valid here. You can choose any point here. You can choose negative 1.5 for examples. Okay. And then for this part, okay, you can choose, maybe you want to choose 1 here. Then you plug in 2 times 1 is 2. 2 plus 1 will give you 3. That is greater than or equal to 1. But in the middle part here, let's say you choose 0, okay, value between negative 1 and 1 over 2. So you plug in here, you will get 0 greater than or equal to 1, which is incorrect. So you are going to reject this one and you are going to accept this interval, okay, and this interval. Or in other words, you can write it as x is less than or equal to negative 1, okay, and union or x greater than or equal 1 over 2. Okay, it's very simple, right? You have to draw and you have to check the validity, okay, between the intervals, okay, the intervals between your critical points. So this is negative 1 and 1 over 2 that we obtained from the calculation. That is what we call as the critical point. And then we check the interval here, this one, and this one. Okay, so you can choose any value. If you want to choose negative 100 here, should be okay. If you want to choose 100 here to be safe, also no problem. Next, we have ratio inequalities. Also very simple. Also want to play with our ability to perform manipulation, okay, algebraic manipulation. So I'm going to go through this one with you a bit. Here we have, we have 3x, 3 minus x, okay, and then you can bring 5x plus 2, okay, multiply by 5x plus 2 on both sides, and then you have 3 minus x is less than 5x plus 2, okay, and then you can perform some simple manipulation, okay, you want to isolate x, okay, I hope you can do this on your own, okay, and then you'll get x is less than 1 over 6, okay, so you have 1 point here, but the next thing that you need to consider is, of course, 5x plus 2, because 5x plus 2 cannot be 0, right? So you need to be careful, okay, with the values that you are going to use here. So 5x plus 2 here will give you x cannot be equal to negative 2 over 5. So you have two critical points here. You have 1 over 6 and then you have negative 2 over 5. And from there, you are going to use your number line again. So now I'm going to draw my number line. So we have negative 2 over 5, for example, here. And then we have 1 over 6 here. So now you have to check the interval. Okay, so you have three intervals less than negative 2 over 5. Okay, between negative 2 over 5 and 1 over 6. Then you have to check above 1 over 6. So sometimes it's better for you to just use equality here because we are finding the critical points. Okay, because after that we are going to draw this and we are going to try to plug in values that we have here, and then you will see that, okay, the values greater than 1 over 6. Okay, you can try plug in. Maybe you can plug in maybe you can try to plug in, okay, 1 for example, and then here maybe you want to plug in negative 1. Okay, it's up to you. You can plug in any value here. Maybe you want to plug in 0 here, but this is the critical points that we are considering. And then you can do the same validity check, okay, like in the previous example. Okay, just now you have to plug in the values, and then you see that, okay, it actually works, okay, for these two intervals. So you have two intervals here. Okay, the first one is this one, less than negative 2 over 5, and the second one is greater than 1 over 6, or you can write it as, okay, x less than negative 2 over 5, okay, or x is greater than 1 over 6. Okay, so you have two intervals here, okay, infinite intervals. So the next thing that I want to highlight is on absolute values. So there are two properties that you might want to see here first. So absolute value of a number A denoted by this symbol. We have the modular symbol A here. Okay, is the distance from A to 0. Distance from A to 0 on the real number line. Since distance is always positive or 0, so we have, okay, this modulus A is always greater than or equal to 0 because we are indicating the distance, okay, for all A. Or we also have the modulus A, okay, is equal to A if A is greater than or equal to 0, and equal to negative A if A is less than 0. So these are properties of absolute value. Okay, you can pause the video and see it on your own. I believe you have seen this before. I think you have learned it as early as in your high school. Okay, and then you also learn the same thing in your pre-university. So you can check them out. Okay, you have the triangular inequality that you might want to see the proof. Okay, how a mathematician come to this triangular inequality in the first place. Okay, you can check it out. So I'm going straight away to the examples. So of course, the first one is very simple. You have modulus negative 3. Okay, it's a distance from negative 3 to 0. So it will be equal to 3. And then the second one we have what? Okay, we have 5 minus 2. Why? Because we have cert 5 is greater than cert 4. Okay, indicating that cert 5 minus 2 is greater than 0. Okay, so we know that the number inside here is positive. And from this one, we know that if A here is positive or greater than or equal to 0, then we have A only. So we have cert 5 minus 2. And then the third one, we have 2 minus pi. Then we have to check whether 2 minus pi is positive or negative, so that we can use this one. So we know that pi is somewhere between 3.142 something, okay, which is greater than 2. So we have what? We have 2 minus pi, okay, is less than 0. Okay, it's a negative number. So you have negative 2 minus pi. Okay, so the fourth and the fifth one might be a little bit tricky. We might need some computation. So let's try to do on D here. So you have 6x minus 2, okay, less than 7. So you have 6x minus 2, okay. You have two options here. You have 6x minus 2 equal to 7, or you have 6x minus 2 equal to negative 7. So in this case, you try to solve for x, and then you'll get x equal to 3 over 2. And then for the second one here, if you try to solve it, you'll get x equal to negative 5 over 6. So there are two possibilities depending on the value of x itself. So x could be 3 over 2 and could be negative 5 over 6. Okay. So the last one here, this one is D, this one is E. So the last one here, we have 3x plus 1, okay, in the form of inequality is less than 4. So we have 3x plus 1 less than 4, okay. So that's the first case, okay. So with manipulation, you'll get x is less than 1. Of course, you will have 4 minus 1, 3, 3 over 3 is 1. So we have x less than 1. And the second possibility is that 3x plus 1 is is greater than negative 4. Remember, we are talking about the distance. Okay, means the distance from this to 0. So we have to consider greater than, because this is less than, this is greater than. So it's greater than negative 4. And after some calculation, you'll see that x is greater than negative 5 over 3. Okay. And then you can also write it down like this one. Okay, you have x greater than negative 5 over 3. Okay. Or x less than 1. Okay. So I hope you have no problem with this one. So next we want to recap on coordinate geometry and lines. So you should know the name Cartesian coordinate. Cartesian coordinate system is the points in a plane that can be identified using ordered pair of real numbers. Consists of two straight lines that intersect at the origin of of each line. So you might get familiar with this one. So we have x and y, for example. So this is the Cartesian coordinate. So there's two lines is known as the x-axis and y-axis. Okay, fixing on the origin. Okay, we have the positive direction, okay, to the right here, okay, and the negative direction to the left here. So for y, we have positive direction upwards and negative direction downwards. Sorry. So this is one example. Okay, so each point P, let's say we have point P here on the line corresponds to a real number, and it is called coordinate of P. Okay, similarly, okay, we can fix an origin 0 here corresponding to the point 0, 0 itself, and take a point P here. Okay, we draw a line through perpendicular axis. Okay, line that is perpendicular to x-axis, you'll get this blue line. Okay, you stop at P here, and then you draw another line that is parallel. Parallel to y. Okay, just now we have parallel to x-axis. Okay, parallel to x-axis, and this one is parallel to y-axis, and stop at the point P. So let's say you have the value here is A and the value here is B, so you represent them as AB here is the coordinate for point P. So this line intersect the axis at point with coordinate A and B, and we identify them again as A, B. So then we have distance between 2 points. So you might still remember formula to calculate the distance between 2 points. So I'm going to just write it down for you again. So we have the distance between point 1 and point 2 that's given to you here and here is given by, okay, the square root of, okay, first we have x2 minus x1 square, then we have y2 minus y1 square. So it doesn't matter if you choose this point first. Maybe you want to do x1 minus x2 square plus y1 minus y2 square. We still give you the same value because it is square and we give you positive value to indicate the distance itself. Next, we have slope of straight line. So if you still remember, you normally use this letter M to indicate the slope. So the slope of a line is a measure of the steepness. Okay, how steep is your line? Okay, the slope of a non-vertical line that passes 2 points above is you have point here, P1 x1 here. Okay, so the slope is given by M equal to the change of y over the change of x. So the change of y here, you can use maybe y1 minus y2, and then the change of x, v1 x1 minus x2. Or it also the same if you take the other way around, y2 minus y1 over x2 minus x1. So lines with positive slope means that it increases from left to right. So if you get its positive value, you get it something like this one on the Cartesian plane. Okay. So if it is negative value, then you get something like this. And also after this, we will see what happened when m equal to 0, where we have a constant and so on. Next, we have equation of a line. To suppose a line passes through point, okay, the same point P1 and P2 again, having a slope m and y-intercept b. So the equation of the line can be rewritten as y minus y1, okay, equal to m x minus x1. So it's the same formula that we have just now. Remember just now we have, okay, y2 minus y1 over x2 minus x1. So it's almost the same formula, but now you bring the elements of x here, okay, together with m. So we have this kind of form, or you can rewritten them as y equal to mx plus b. Here we are not going to you know, state which y is this. We are going to be general because we want to make sure that this equation represents every single points on the line. That's why we call it equation of a line. So it's valid if you plug in any value on the line to this equation. Okay, you can try to check it, validate it. Or in a more general term, you can also rewriting this y mx plus b in this form as ax plus by plus c equal to 0, or you can also write it down in this form, x over a plus y over b equal to 1. Okay, a and b are x-intercept and y-intercept respectively. So there's just some different way to write the equation of a line, but don't really matter to me. Can choose to read any of this, okay, as long as it's the correct one, then I will still accept it. Okay, unless it's stated that you have to write in the form of y equal to mx plus b, then you have to write in that form. But if it is stated generally, give me a equation of a line, so you can choose either this one, or this one. So I guess okay, we have parallel and perpendicular lines. Okay, you still remember parallel lines is what defined as two non-vertical lines. Okay, we say the two lines are parallel if and only if they have the same slope. So you can have like this one, okay, you can have like this one, and so on. Okay, move, okay, together but never touch the other. Okay, it's not meant together. Okay, and then we have second one, we have perpendicular. First one parallel just now. So perpendicular, okay, normally we will represent them with right angle. Okay, between this line and this line, you will have right angle. Or in other words, okay, if you multiply the slope of this first line and the second line, you will get -1. So these examples, okay, is an exercise for you that you have to submit via e-learning. So if you still don't remember how to find the equation of line, please take your time to browse or to Google. Okay, read some articles on how to construct equation of a line. Okay, we have two different questions, but still using the same concept. So second one, we use a perpendicular, m1, m2 equal to -1. And then the first one, okay, we have the slope already, and then we have the point. You just have to rewrite it in the form of y equal to mx plus c. But of course, you need to find your c. I guess that's it. Thank you.